Hello everyone. This video explains Chapter 10 RC series circuit under constant and square voltage. So here we have the screen of an oscilloscope showing U across a low frequency generator delivering a square signal and the voltage across a capacitor. In figure 3, we have an RC series grouping under a square voltage. So we have the resistor in series with a capacitor across a square generator. The square generator delivers UG equals E during the first half periods, so from 0 to T over 2, and 0 during the second half period from T over 2 till one complete period. Figure 4a shows the screen of the oscilloscope, so the square generator is delivering a voltage E during the first half period and a voltage 0 during the second half period. So, how is the behavior of the capacitor during this time? To show the voltage across the capacitor, we connect channel 1 with the ground M across the capacitor. So we can observe the increase in the voltage across the capacitor during the first half period and the decrease of the voltage across the capacitor during the second half period. While channel 2 and the common ground are connected across the square generator to visualize the voltage UG equals E, then 0 during one complete period. In figure 4b, we have a graph showing the voltage E across the generator during 0 and 6 milliseconds, so during the first half period. Then UG equals 0 during the second half period from 6 till 12 milliseconds. And during the first half period, UC increases exponentially. And during the second half period, UC decreases exponentially. Applying the law of addition of voltage, please observe figure 3. UAB across the generator equals UAM across the resistor plus UMB across the capacitor. During the first half period, UAB across the generator equals E equals UAM across the resistor, so UR, plus UMB across the capacitor, UC. During this time, UC is increasing as shown on the graph. So UR will be decreasing since UR plus UC equals a constant value E. So in figure 4C, between 0 and 6 seconds, so between 0 and half period, UR is decreasing. Now, applying Ohm's law, UR equals RI. So during the first half period, as UR decreases, R will be decreasing since UR is the image of I. What happens during the second half period? During the second half period, we'll apply the same law of addition of voltage. UAB equals UAM plus UMB. But now the generator is delivering 0 volt equals UR plus UC. So UR equals minus UC. Then as UC decreases, UR will be decreasing in value as an intensity or an absolute value, but in the opposite direction. So not from 10 till 0, from minus 10 till 0, like this. also the current I will be decreasing in absolute value, but in the opposite sense. Okay, since UR is the image of I. Why? Since during charge, the current is leaving the generator and entering the positive plate of the capacitor. But during discharge, the generator now is acting as a connecting wire. So it's like we have a capacitor, the resistor, and a connecting wire. Now, the positive plate of the capacitor marked as Q, it is the plate M, where the current I is delivered. So the current I flows in the opposite direction. This is why I as a value is decreasing from maximum till 0, but as a direction it is from the opposite direction or in the opposite sense. Since now the current is not entering the positive plate of the capacitor, it's leaving the positive plate of the capacitor, since during discharge, the capacitor is the electrical component that plays the role of the generator of current through the circuit or through the resistor.